So maybe you would agree or disagree so far. Um, this is probably going to perhaps set the stage for, I would think, not only the next 2 years, but you would possibly be looking at this and thinking this is so much more interesting than anything we've done the prior 29 weeks, 30 weeks, somewhere around in that vicinity. And the reason I would say that is you can probably relate to this more than anything else. Okay, and the most common characteristic that are yeah characteristics. Some of these traits you can see on the outside, but if you know anything about the internal anatomy, you know this is taking place on the inside as well. So you're looking at something and you can see that is a mammal. I know that. Why? Because it has hair. Okay? And for some of you who go on to take zoology, one of the aspects that we talk about as the animal kingdom had evolved to for animals to fit into the certain ecosystems that where they were successful is a certain transformation that you would see between that of the amphibians and then the reptiles, and then ultimately the mammals. And we've talked about that before. And on one of your part 2 exams for evolution, I wouldn't expect you to remember that, but probably the meanest that you would have seen up there, does anyone remember what it was called? It starts with a G. The Gorgonopsid, right. That just rolls right off the tongue. How did you know that? Just remember it? Just want to have a mind like a steel trap. Okay. But with that, God darn it, I lost my train of thought when you said steel trap. Obviously, I don't have one, but that's okay. But what characteristics made that that animal, that Gorgonopsid, maybe start to see the transformation towards the mammals that you would have seen? Its legs were getting closer to being placed directly underneath them, but think of the diet of that animal, which was what? Carnivore. So when we look at modern carnivores now, you have to have, it doesn't even have to be carnivores, they can be omnivores as well, which a lot of you people probably are. Okay? So, in case you're wondering what that means, you're going through the lunch line and you also grab a salad. But then, who wants just lettuce and then salad dressing on top of that? Maybe put some scrambled eggs, maybe throw a little ham on there. Then, yeah, there's your definition of your omnivore, having both plants and animals as well. Okay, so as we continue forward, it's going to be the idea of hair is going to be the biggest distinction for that of the mammals. Now, this can come at a cost, and that cost is what? What you had just asked earlier about 3 minutes ago. What was it? Mm-hmm. Someone help her out. I said they mean the same thing. Endotherm and endothermy. Endothermy is the process that these animals do. They have the same temperature as their surroundings, or do they maintain their own body temperature? Yeah, they maintain their own. It's something that we're not, let's say, limited to outdoor activities because of our internal metabolism. Okay. And we may have talked about this up to this point, and then major characteristics that we see is the opportunity for to take care of our young, to feed them. And in this case, okay, you know, you can just take the young along with you. That's not a characteristic that most animals have, especially reptiles and that of the amphibians, and as well as once those hatchlings take place, or actually leave the nest, if you want to call it that. They're on their own, and cannibalism is no stretch of the imagination, which would mean what? Yeah, they'll get eaten by their own species, okay? But that is not the case here, okay? Mammals do, in this case, a better job of taking care of their young. So if we place humans in mammals, we can say, yes, we're doing a good job of taking care of our young. And you're nodding your head yes. So are we doing a good job? How does the software going to say that? Have you taken that home yet? Can anyone comment on the sleep cycles that's going to take place? What will it be like? No sleep. No sleep for you. Okay. 4 hours. Well, that's probably normal anyway, right? No? Okay. Sure. All right. So when we see this, okay, these ingredients right here, especially in the first, let's say, 6 months of that offspring's life, something that comes to mind is ungulates. That's one of your vocab terms. What does ungulate mean? It's a hooved mammal. Okay, so we're getting closer. Now we're gonna say an artodactylian. That's one of your orders that you'll have to know. That is an ungulate that has an odd number of toes for hooves. So if that's the case, that might be 1 toe, might be 3, might even be 5. But in this case, we're just going to say 1. So the most common ungulate that only has 1 toe on their hoof would be what? Horses or zebras. Okay? So with that, when you look at some of them, is that the correct nomenclature for a young-born horse? Okay? So let's say that horse is born in the wild, the mare and the foal. If that offspring can't get to its feet, would be no stretch of the imagination that you might see Wiley out there running around. Wiley and his friends. Who's Wiley? Wiley Coyote and his buddies. Okay? So with that, this milk then provides all these vital nutrients within even just hours of after them being born to, when you look at that foal, its legs, they look so brittle, they look so small, but within that first 6 months, that foal is really going to get bigger because of this right here, okay? It has all the ingredients that it needs, okay? Probably the most important one is this one right here, sugars, to help put on the weight fast, and then this giving it the energy that it would need. All right. So when we look at this characteristic right here, okay, these two do tie into one another, and the idea for this is going back to your little buddy, the Gorgonopsid. Okay, what was it that animal had in its mouth to make it so successful for its time frame on Earth? Okay, so it has incisors for grasping, and tearing and cutting. But even more importantly, these on the picture that you'd seen, true, probably has molars. These teeth stick out. Yes, the canine teeth, okay? So what we see here, okay, reptiles have many teeth for grasping, okay? And for the most part, they're all uniform in shape, maybe not quite in size. So a common reptile that comes to mind would possibly be, you can just spit out anything, really. Reptiles. Okay? I would say the chameleon is a better example, snakes as well, but alligators, crocodiles. Okay, so with those animals, they've got conical teeth. The caiman, alligators, and crocodiles. The, did you say Gila monster? Oh, chameleon, okay. Well, we're going to say Gila monster, they have all the same size of teeth, maybe very similar to that of alligators and reptiles. But what about snakes? If you are silly enough to pick one of them up, okay, you could, if it's in the order of non-venomous types, you could get bit. It is probably going to hurt. And you're already nodding your head yes. Okay, so you don't have to worry about getting envenomated, but still, what about them though? What about the teeth? It's not that they have the fangs, but they're long and they're very pointed and sharp. And one of the things is you get bit on the hand and starts to chew and move its mouth. Well, not chew, but starts to try to grind and get them teeth to go further in. You're not going to be able to get it come to pull in the opposite direction, are you? So a lot of you are nodding your head no. What is it that you actually have to do? Get the mouth open and move it even further into its mouth. Why would that be? Okay, the most logical answer came from there, and that, well, not that yours is wrong, but why, what did you say? Yeah, they're pointed backwards, so you have to go further in so it'll actually let go. So, also these animals, okay, it's for grasping, not really chewing, because when you look at these, they either have to swallow their prey whole, okay, or they got to take off bits and pieces, and we're talking large bits and pieces. So an advantage to that would be if you can feed yourself at your own leisure and be successful in having many different types of opportunities for your diet, that's certainly going to be an advantage in why the mammals are quite so successful. Okay, so we will start with just a couple of the orders here, and that was handed out to you earlier. And with these, we just kind of pick and claw our way through here. So the paper that you see, okay, has all the mammalian orders on there. It doesn't have this as a title. There's the dot, okay, the single dot is gonna be the order, all right? Then every dash underneath there is gonna be a characteristic of that animal or the actual name of that animal in that order. So to make sense of that, okay, if we see this term, monotremata, platypus or the spiny anteater, or I think echidna is another fancy name for them. So the dashes that you see, some of these are probably already filled in. So these are characteristics of these animals, and then that's an example of that. So very similar to what you have for paper, just picture each one of them as a box. And in that box, it might say monotremata on top, and maybe one or two of these characteristics give the other two, and then the animal in that order. Or we'll give you a different example here in just a moment. I don't have this information that once. Okay, so another example would possibly be if you had seen, I guess from our discussion earlier in social studies room, the idea that there's possums or opossums. Maybe you just see this. This is the only thing you see in the box. You have to give two characteristics and then the name of the order that kangaroos are in. Okay, so you're not limited to just what's up here, because some of you already gave examples of marsupials that are not up here. And if you follow the Big Bang Theory, it's Sheldon's weakness. This bear, the koala bear, yes, that is possibly his weakness there. One of the things that I would like you to think about here for just a moment, there has to be a reason that either the man upstairs designed these animals this way, or it's just the idea that nature selected them to do this. The key is right here. Okay? When you look at the immature young, of course they would be, my guess, about the size of a salt and pepper shaker. I think that would be a pretty fair presumption on what perhaps these guys would look like when they're born. So why would nature select these animals to be, yes, born alive, but so small? How long would it take to produce a viable population if they're born immature and young, do you think? Immature means what? Pretty quickly, because when we look at our gestation period, it's about the same as a mammal that's going through that right now here in the Midwest. It's this season that's taking place. No, it's not pigs. Yeah. Cows go through about a similar gestation period. And that means what? What is a gestation period? Does anyone know? Come on, shop or egg people. Maybe you haven't talked about that. Yeah, it's the pregnancy for that animal. And typically, the larger the mammal, I think you would agree, the longer the gestation period. So there again, why is this an evolutionary advantage for their population? Yeah, you can produce more in a shorter amount of time. Okay, so that would be again an evolutionary advantage for these animals. So that is 2 down, maybe 11, 12, or 13 to go. Again, we'll continually pick and claw our way through these. And it might look daunting right now, but one of the things I think that makes the most sense, at least that's what I would think, and hopefully you would agree with this, is as you go through some of these, if you can just picture the animal, okay, well, we know that these are born immature and that they develop in the pouch. If you can picture what a duck-billed platypus looks like, you know that they've got a wide bill. It's the only species that lay eggs, okay? If you can visualize these animals, let's pick another one. For instance, these guys, okay? If you can picture what their diet is, okay? So we said don't just fixate on one characteristic for that, because echolocation, is that just unique to one order of mammals? No, it would be unique to what two? Dolphins and bats, okay? Feeding on insects, is that just unique to that of the order Insectivora? The answer is no. Who else feeds on insects? That are mammals, though. That are mammals. Okay, anteaters, bats, of course, shrews, okay? Any one of those, they all feed on insects. So you don't want to just limit that to just one characteristic. Again, the more you work on that, the more you'll be familiar with it. Okay, so we will continue with this next time. As we look forward, we're still just talking about characteristics of mammals. Of course, no class on Friday. And with the weather forecast, let's keep our fingers crossed. Let's try to remain optimistic. Okay, so we'll be all right. We're winding down pretty quickly. With that, we got to get through the rest of these orders, and then after this chapter's done, okay, then there's just one left, and that deals with human skin, bones, and muscles. And then by that time, that's it. There isn't a whole lot of material with that of next chapter, but there's a lot to know when it comes to these bones. Have you had health class? That's juniors. Okay, so is this nutrition and development that you're parenting? Okay, I guess you don't need to be listening to this. We'll catch up next time.